Hello, welcome back to I Say Our Wrong Reads, and today I'm going to be giving you some recommendations for some non-physics books. So today I thought that I would put my degree into some good use and recommend you some non-fiction physics books that are easily accessible and are very interesting. So for example, I've split it into three main sections. So the first section would be just the history behind the physics discoveries and that sort of thing. And then the second section is easier entryway non-fiction books, and the second section would be a bit harder to understand but very rewarding if you can get through them. So first up, we're going to be talking about the history behind some of the most famous discoveries of physics. So first things first, let's start with how we determined the distance to the sun, and that you can find out more through Chasing Venus by Andrea Wulf. This is a really good book describing how people determined the distance from the Earth to the sun by measuring the way that Venus orbits it, and because we can only see it from Earth every about 100 years, roughly. It took a long time for them to actually band together and do it, and it actually tells a story of everyone across the world coming together to measure this distance in a time when it was very difficult to get people to do things together in the first place. Next up is The Glass Universe by Sobel, and this tells the story of a number of women who were the first computers and astronomers of early astronomy in the late 19th century. It essentially tells them how their discoveries shaped astronomy and what they did to create what the foundations of modern astronomy today. All these women were particularly amazing, and most of them created systems that are still used today. And lastly, in our history section, we have Black Hole Blues by Janna Levin, and this tells the story about the discovery of gravitational waves and the main people who helped it get there. So we've got, in 1916 was when Albert Einstein first predicted the existence of gravitational waves, and in 2016 is when we discovered gravitational waves for the first time, and the people who were involved actually won a Nobel Prize for their work, but it tells a story of the people who got them there, and particularly the ones that didn't manage to survive to see them win the prize. It is a very good book, but very sad towards the end when you just read about how just kind of life works and that kind of thing. Next, we're going to go on to some of the kind of more entryway level of prose from non-fiction books, and probably the easiest one to recommend to people would be two different books by the same author, and that would be Stephen Hawking. Stephen Hawking was one of the most prolific scientists in the public eye, probably in the late 20th century and early 21st century. He has studied black holes, and there is a type of radiation named after him called the Hawking radiation. So the first book that I'll be talking about is A Brief History by Time by Stephen Hawking. This is one of his older books, and it is a very interesting read, just to give a glimpse into where things stood even 20 years ago. Astronomy and physics in particular are two subjects that move very fast sometimes and move very slow in other times, and that's why this book is an interesting see and to get you caught up to that point, which then you can move on to new points. Another one by Stephen Hawking, which is very good, is Brief Answers to Big Questions, which this is less a physics book and more just a series of essays written by Stephen Hawking towards the end of his life, and it's got an afterword by his daughter, which was lovely. And I would definitely recommend this one along with The Brief History of Time, because I do think they pair each other very well, especially because in this book there is a number of threads that he picks up from A Brief History of Time that continue on and they develop in more detail in this. Next up, we've got two books by the same authors. There are two authors in this one, and those are Andrew Cohen and Professor Brian Cox. Andrew Cohen is the head of the science department at the BBC, and Professor Brian Cox is a physicist at Newcastle University, I believe, or Manchester, one of the two. So these two books are on completely kind of different parts of physics and astronomy. The first one is Forces of Nature by Professor Brian Cox and Andrew Cohen. And this talks about the forces that are at play in our universe at a very accessible way to make things a bit easier to understand. So there's not throwing in all these maths everywhere and making things very complicated. It actually just explains it in a very friendly and accessible way. The forces that make up our universe, like the strong force, the weak force, electromagnetic force, all these different kind of things, they explain it a lot better than I could, for sure. And then it kind of, towards the end, it gets into how these forces affect bigger things like life on other planets and space and time and the nature of it, and also it also does a good job at kind of developing the history behind it as well, but it is mainly focused on explaining it. So the other one by Andrew Cohen and Brian Cox is The Planets. So this is definitely more rooted in astronomy. This is essentially just talking about the planets and how they came about, the history of them, what they used to be like, what we know about them, when they were first discovered by people on Earth, and certain cosmological probes and probes that were sent up by NASA and the Soviet Union and ESA and Japan and all these kind of different space agencies to discover more about these planets. And it's got some of the most beautiful images I've seen in a non-fiction book, like these ones here of some of the gas giants, and this one in particular of Io, which is Jupiter's largest magnetic moon. And then you've got other things like the Curiosity rover. It talks about that, and then people landing on the moon. And in particular, it does also follow every single planet, so it does include Earth as well, which shows you the development of how our planet was created, which is a great entryway into finding more about the basics of our universe. The next one that I'm going to be talking about is Paradox by Jim Al-Khalili. So this book is essentially talking about 9 different famous paradoxes or enigmas that have kind of plagued human knowledge from the start. So it starts from Aristotle's problems and various other kind of maths and physics and astronomy issues or problems that have kind of captured the human eye. Most of these have actually been solved, so you're not going to be left kind of hanging at the end with not really knowing an answer. All of these have an answer pretty much, and it's taking philosophical problems and applying them to maths, physics and astronomy and engineering to a lesser degree, but we don't talk about that here. So that's definitely a good one. There it talks about the turtle and the hare and that kind of level of stuff, and also the game show paradox, Monte Carlo paradox, which is beautifully described in Brooklyn Nine-Nine, and shows you the logic behind them so that it makes you feel a bit smarter. Just pre-warning, the ones that are coming up next are slightly harder than the ones that came before it. These have got slightly more maths in them, and are a bit more complicated in these kind of things. So next I'm going to be talking about the 3 books by Carlo Rivelli. So Carlo Rivelli is a quantum physicist in Italy, and he writes about quantum physics and reality and particle physics and that kind of thing. So he had 3 books out. The first one, 7 Brief Lessons on Physics, is actually really accessible, but definitely on the harder scale, I would say, and has beautiful prose, and the way it's written is just gorgeous. And it just talks about 7 like easily digestible kind of gateway things into physics. Next up, we have The Order of Time by Carlo Rivelli. So this book is essentially just telling you about time and how we measure time and what it actually means on a physics and astronomy scale, because the way we measure time and we think of time isn't really how physics thinks of time, because we just think of time passing, and whereas in physics it's mainly a fourth dimension that can be changed and altered and pulled and tugged and that kind of thing, and this does a really good job of explaining that and making that come across a bit easier than perhaps it might seem. It also explains how time isn't really made up of seconds and minutes but events, and the way that the universe reacts to the events, and how time travel could work theoretically but doesn't really, because it's all about moving forward through events and the reactions that those events give. I think it got a bit more complicated there, so I do apologise. The last book is Reality is Not What It Seems, The Journey to Quantum Gravity by Carlo Rivelli. So quantum gravity is one of those theories that are very prominent right now, but still hasn't entirely been proven, and has a lot of work, especially right now, going on with it at CERN and in certain universities all across the globe. So Carlo Rivelli does specialise in quantum gravity, so this book is essentially about his subject, it's his expertise, and he wrote this book. It connects like from the very first things, so the early human investigations of like the Arabic Empire and the ancient Greeks, and works together to bring that to now, stopping along at like Newton and Einstein along the way, till what we have now, which is very much a developed theory, which is just waiting to be discovered, almost. And definitely it's probably the densest of the three books, but very rewarding. If you manage to get through the other two books and you enjoyed them, then I would definitely recommend this one. It is a bit heavier, but it is really interesting to discover the path that sometimes gets to one particular theory and how you get to that, and how it's developing in the future. This book also sometimes talks about the equations and diagrams comes with it. So again, it is a bit more dense, but would recommend. So the next one that I'm going to talk about is another Brian Cox one, and that is Everything That Can Happen Does Happen. And again, similar to the last one, it is about quantum physics. So I might be mentioning quantum physics a lot, probably because it's the sub part of physics that I find the hardest. So whenever I try and read about it, I search out more books to do with it because I don't understand it that much and I want to. It is very dense and can find it more difficult to get through, particularly because it does seem a bit dry at times because you're just essentially talking about particles constantly. But it is a very good way of depthening your knowledge and discovering more about that particular subject in a very kind of accessible way, because I do find that Brian Cox's books do tend to be quite accessible, even though I do enjoy Andrew Cohen's prose a lot more. The information is a lot more accessible when Brian Cox is talking about it. Okie dokie, with 3 books left to go, we've got next one, In Search of Schrodinger's Cat by John Gribbin. So once again, this is about quantum mechanics. So like I said before, it is probably one of my most difficult subjects to get hold on, so I do try and search out more quantum mechanics because I feel like it's definitely the one that boggles your head the most. So this essentially tells the story of quantum mechanics, so where it started and where it ended up, going through Schrodinger's equations and in particular his famous cat. So if you've not heard of Schrodinger's cat, it's essentially the cat in the box that you don't know if it's dead or alive if you open or shut it. It's a lot more complicated than that, and it's all about decaying of radiation particles and stuff like that. But this does a really good job of explaining that in a way that doesn't kind of make you want to cry. It also does a good job of applying those principles to other things in life, like chess and just ordinary day-to-day life, and how that affects, and talks about the macro states and micro states of physics and how things change when you're on different scales. It also goes quite a lot into particle physics, and so essentially like electrons, neutrons, bosons, those kind of things, and talks about the Standard Model, because in reality, although we like to talk about different sectors of physics, everything is all interconnected and you don't have one without the other. So even the furthest away astronomical research into like dark matter and the structure of the universe, all it comes down to is essentially just particle physics, slightly nudged over into astronomy, and everything is like all connected and overlapping and things like that. So a discovery on one side of the board might not directly help something on the other side of the board, but it's going to affect it somehow in the way that we view it. And that's definitely a good way of seeing how that works and seeing the interconnectedness between everything. Okay, and up next is probably the hardest and most difficult to get through book that I have read and to do with physics, and it's Our Mathematical Universe by Mark Tegmark. So next up is probably the most dense and most difficult of books to get through, in my opinion, but again, I definitely think it's worth it if you feel like you can manage it. And that is Our Mathematical Universe by Max Tegmark. So this is essentially just physics, the maths behind the physics, and it explains it in interesting ways that definitely cement the ideas in your mind, but it's quite difficult to grasp at some points. It's probably well known that a lot of physics and astronomy is just based on maths, but it's a different type of maths than pure maths. And it can be a bit confusing at times, especially if you know pure maths and you come to physics and you're like, what are they doing? They're nuts. And that's definitely an interesting thing you find when you're studying physics, is that you might get taught something last year in a certain way, and the next year you'll be taught it in a completely different way, and you've got to try and figure out how they're connected. And this book does a good job of this. So this book I would recommend a lot to especially early students who want to study physics and struggle with the maths side of things, because this definitely explains it a lot. So it does have some nice funky diagrams, and it goes through a lot of famous physics problems like symmetry and solid state physics and astronomical physics, quantum mechanics, and describes the maths in between them and the certain cosmological principles. Like such. I would definitely recommend it, but it is, once again, probably the most dense book I've ever read on this subject, and I study physics, so it is very much of a muchness. So lastly, we've got the honourable mention of sorts, and that is Cosmos by Carl Sagan. Now, this is probably one of the most famous physics books out there, because it just does such a good job of drawing you in and talking about it and getting across the information in a really, really good way. And if you haven't read this book, then I would highly recommend you go and do that now. Well, not right now, but soon, because it just gives you such a unique glimpse into both Carl Sagan's mind and the universe as a whole. And it's just very, very beautiful prose and really nice to read. It's just a really good book in general. So these are some of the non-fiction physics books that I've read over the years. I'll likely be reading more in the near future, so I might do an update video to this at some point in time. But if you've got any questions about any of these books, then please do leave a comment down below. There are a list of these books down in the description if you want to check one of them out, but can't remember either the author or the title. And thank you for watching, and I'll see you next week.